Oh, hi there. Thanks for showing up for your students' learning. I'm Grant Jennings, and this is a game I developed for grade 9 students to practice working in the XY plane, as well as working with the equations of circles and Pythagorean theorem, and finding the size of triangles, the area of triangles. So there's actually a number of ways that a grade 9 student can calculate the area of a triangle in the XY plane. Probably the most straightforward that you can coach them on is looking at it as a composite shape. So I'll show you those towards the end of the video when we get to scoring. Okay, so I'll play one round of the game here and then I'll score it. So to play this game, and I'll show you the equipment that we have down here, you're going to want either this printout, which is available in the games package, or you can have students play, and this is like the scoring board, so you can have them score one game on here, and one game might take a whole period. Like this is kind of time consuming. At CCI, we really like this product, the Learning Advantage. It's 20, well, it's 10 by 14 that way, so it's that 29 this way and 21 that way. And, that big of a board. It's the same as this. It's the same as the printout. Okay, so I'm going to be playing on the whiteboard, but you could have your students play on this beautiful handout as well. So let's go ahead. And so they're going to need those things, and they're going to need whiteboard markers, pen and paper. Let's go. And a ruler doesn't hurt either. It means they have to do a little less Pythagorean theorem, so it's a little bit less spicy for them. So the objective, this is based on like the triangle offense of the Chicago Bulls, where you wanted to be able to create triangles of your players to give them lots of offensive opportunities. And so there are ways you could chat this game up to increase the visualization of coolness in your students' minds and add to some of the fun. You can also play in Desmos. Let's not forget Desmos. This Desmos screen is available to you here, and it's got instructions on it for where to place your offensive and defensive players and how to write them. And I even show you what an example half game might look like as people are finished. Okay, so one player is the offense, and they're going to be placing players different distances from the edge of the half court. And then the other player is the defense, and they're going to be covering areas of the board with circles that are now no longer available to have players placed inside them. And the offense's goal is to create the largest triangles possible. The defense's goal is to limit the size of the triangles possible. And the final score of a half is the total of the area of the largest triangle that can be formed and the smallest triangle that can be formed. So you add those two areas together, and that's the offensive player's score. And then they switch roles, offense and defense. Okay. So let's go through an example game played by hand here. So we'll come in here, zoom in on our board. Come on over there. Let's go play the game, everybody. So here we go. We'll play on that side of the board. Zoom out just a little bit. I'm actually a little bit surprised that that's not strange. There we go. That's much better. Okay, so now we're ready to start. So the defense places first and chooses to cover some area of the board. And they get 5 players, and the radius circle that that player covers decreases with each player that they place. So they'll place a radius 5, and radius 4, 3, 2, and 1. So they say, well, I want to take away one big area of the court for you, so I'm going to go ahead and put my first player there. Radius 5 certainly goes off there, and actually with the 4-3 triangle, you can coach them that those points are gone. That point, 5 away is that point. I'm not trying to play optimally. I'm trying to show you how this game works. So that would be what my circle would look like, just using Pythagorean theorem and the 3-4-5 triangle. And then I go through and I mark all those areas and all those intersections that this player covers as now unavailable in this game for offensive player placement. Now it's the offense's turn. Oh, and I might write down what's the location of that per spot. So that's -1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's -10, +6. So So this was at negative 10, 6. Okay. Now the offense is going to place their players, but their players have similarly constrained positions where they can be placed. The first one can be placed as close as 1 from the edge of the half court, and then 2 from the edge, 3 from the edge, 4 from the edge, 5 from the edge. So they're increasingly constrained. So the offense might say, well, I want to get as far away from that as possible. I think I'm going to go down here to place my first offensive player at the point negative 13, negative 9. And so let's just write this down here for posterity. Negative 13, negative 9, and then keep going. Okay. And so then, well, the defense says, I really don't want you to be able to place something up there because then you could make this really large triangle. So I better cover that. But then you're going to go down there. So I have like tough strategic choices to make. However, I also know that you're limited in that you can only place 2 away from the edge. So I really want to take that spot away from you. And so I'm going to place my next one there. So this is radius 4. And so that would be this point here is gone. Actually, I could go over here, couldn't I? Can I go over there? So let's say I decide to place here, and that's 4 away. That's 4 away. That's 4 away. And then I want to see, well, am I taking this away? That's 3 and 3. So is 3 squared plus 3 squared greater than 4 squared? It sure is. So actually, I have left a chink in my armor there. And so then it doesn't really matter what's happening over here, but this one is not covered. So we're in there. The next point that's covered is that point. And we can use Pythagorean theorem to prove if we're covering a point or not. So that's my circle. And you could have them use a ruler and draw the circle around, or a compass if you have such tools in your classroom. I don't tend to have compasses in my classroom, but perhaps you do. So there's the next defensive player, and it was placed at negative 5, 5. Probably moving that over 1 would have been a good choice for the defensive player. So we'll write that down. Negative 5, 5. And then we'll place another player 2 from the edge. And haha, yes, I am going to go ahead and claim that spot because that looks like I can start making some really big triangles here with these this player down here, that player up there. So that's negative 2, 8. And then we'll place a defender with radius 3. Next is the defender, and I'm saying, well, I really need to take this area down here from you, don't I? And the most dangerous point you could take would be there, because it's 3 from the edge that way, 3 from the edge that way, so I absolutely want to take that away, and I'm sure that this point will cover that, because that goes out by 3. It definitely covers this, because 2 squared plus 2 squared, and you could have them draw these little things down, that's a 2, that's a 2. So if we had is that going to be bigger than 3? No, it's not. So this is going to absolutely cover that point, and it's going to cover that point as well. And go out to here, and it's going to go around that point and go all the way up to here. And they can prove this with Pythagorean theorem, or they can prove it for themselves visually with a ruler, okay? Just to know that, yes, we are indeed covering that point. That like 2 away gives you square root of 8 as the length, and that's less than the square root of 9 or 3. So anyhow, there would be our next defensive player, and it's been placed at 1, 2, 3, 4, 5, negative 5, negative 5, negative 5, negative 5. Okay, yes, directly underneath that player. Oh, so interesting. Okay, so that's at negative 5, negative 5. Well, now I get to place my third offensive player, and I want to go 3 from the edge. I'm going to take that one there. That looks really juicy to me and like it's going to be great for scoring. It's 3 from the edge that way. So this is at negative 11, 1. Cool. I've got a pretty big triangle going already. I couldn't go over there, but that looks like the next best thing. So negative 11, 1. Okay, now I get to place a circle with radius 2 down. And now I'm really not thinking about limiting the biggest triangle that they can make, but really making the smallest triangle that they can make as small as possible. So I would love to get them having to place their next player like collinear with a couple other points or something. So the smallest triangle actually has an area of 0. So let's say their next player has to be placed 4 in from the edge. So that looks like a pretty good spot, or maybe even like down there a little bit. So I'm just going to just assume that this is a pretty good spot here and say that my 2 circle is going to cover this area. And you can have them use a ruler, but they should be able to tell you that that's definitely going to be inside that circle, even just visually without a ruler. So that's my radius 2 defender, and it was placed at -11, -2. And then we're going to go 4 from the edge, and over here allows me to really stretch out some of these defenders. So I'm going to put my next one down there. It'll avoid some collinear problems and things. So I'm going to put this attacker down there. And that's 4 from, that's only 3 from the edge. No, it has to be over here. Okay, so then we're -4, -2. Okay, and now we place a circle with radius 1. So I would like, and I know you have to be 5 from the edge, and I really want you to be collinear. So I think blocking off this area there, because if you're 5 from the edge, like over here, you're pretty close to collinear there. So as close as I can get to like collapsing that triangle into nothing would be good. I think I'm going to try and take away area down here, just because if I can get you in there with your point, then that triangle becomes smaller that way. So let's go for my last defender, being 5 from the is there. So yeah, let's take away this group of points right here. So I'm going to, well, just put it there. So this area is also covered. Those 5 points, this one, this one, this one, this one, and this one are the only points that defender covers. But hey, we're trying to force them into a small triangle. So that was the point -1, 2, 3, 4, 5, 6, 7, 8, 9, -9, -4, -9, -4. And then the last thing to do is to place that last attacker. It has to be at least 5 from the edge, all edges of the board. And it looks like I've been forced into this area over here. 1, 2, 3, 4, 5. See, I can't use that point there. And so it's like really this small box in here that I can place in. So I have to go in there somewhere, and I don't want to make a very small triangle. So gosh, I think it might be there or something. Don't overthink it. Just go for it. And that's at -1, 2, 3, 4, 5, 6, 7, 8, 1. -8, 1. Okay, so now we've got all of our stuff done. Now the offense draws what they believe to be the biggest triangle available. So the offense might say, I think this triangle is the biggest. So I'm going to go here with my ruler, boop, and then there drawing careful lines with a ruler, and there careful lines with a ruler. This is my biggest triangle. That one actually looks kind of big. No, that one. No, I think this is the biggest. Anyway, if they want to calculate which is the biggest triangle, have them go for it. Okay, and then the defense will choose what they believe to be the smallest triangle. I believe in this case it's this one here, and this one actually is interesting. That's cool because it's got a straight line. It's got a line parallel to xy on it, so this one's actually very easy to calculate its area. Okay, so now, so we have triangle B big and triangle L little. So the big triangle is defined by the points, and we can just write down the points over here for posterity. -2, 8. And this one was -11, 1. And -13, -9. So I have them write down their big and their small triangles. The small triangle was -11, 1, -8, 1, and this point down here, -4, -2. Now, we want to find the area of both of these triangles, and so let's have them do that. If you want to teach them Heron's formulas and have them use Pythagorean theorem to calculate the length of each side, and then use Heron's formulas to calculate the area of these triangles, that's very spicy, and that's amazing. And we never really teach Heron's formulas, but they're super cool. So maybe try that with your spicy students. Otherwise, this triangle here, if the students can recognize that it has a height of 3, a base of 3, then this has an area of 4.5, because 1/2 base times height, and so they'll work that out here, and it has area 4.5. Circle it, sure. All right, now let's calculate the area of this triangle, thinking of it as a composite shape. So I would have students go ahead and sketch it out somewhere. In the back of the sheet is a great spot to sketch it out. So we have up here, -2, 8, and then down here was -11, 1, and then down here, -13, -9. Okay, so then if you're not sure how to do this as a composite shape, what I'm talking about is this is an opportunity to chat with your students that we need our base and height measurements to be at right angles for that to be a legitimate measure of area. You don't measure the area of rhombuses by measuring multiplying one of the slant sides by one of the other sides. Collapses to 0 if we do that. So, but in the XY plane, you can always create these composite shapes. Sorry, this is the triangle here, where I can have this triangle's area. So the area of the triangle that I'm desiring is equal to the area of the big rectangle minus the area of triangle 1 minus the area of trapezoid 2. So trapezoid 2 is up here. And we go across there. So trapezoid 2 is actually this trapezoid. And so it has a base of 2, because I go from -11 to -13, and a height of 17. Okay, and then a base of 2, a height of 17, and a smaller height of 7. Okay, and then this side here, then this triangle here, this is this trapezoid 2, and then triangle 3. So minus area 2 minus area 3. And so this is great for getting them to use composite shapes and understanding like how to find the shortcut for these types of calculations, which is to lay it out this way. So the area of the rectangle in this case, do you want me to, I'm just going to pause the video and then do my calculations. You don't need to test my math skills. You're not interested in that. You're interested in getting your students playing. And so at the end of the day, that big triangle scores 38. So don't take too close a look at my work. It's embarrassing. And then, so the big triangle scores 38. And so the total score there was 42.5. And then the players will go ahead and play on the positive side of the board, well, the positive X side of the board in quadrants 1 and 4, and fill in the bottom half. Play a few games of this, and I think you'll be pretty confident plotting points in the XY plane. It gives you a chance to coach your opponent if they're having trouble, like where does the X coordinate go, where does the Y coordinate go? Hint, they're alphabetical. And also calculating the areas of triangles and using Pythagorean theorem and relating that to the shapes of circles and finding the triangles inside circles. So I hope that your students enjoy this game. I hope that you like using it in your class to get your students a little bit more competitive and pushing each other a little bit with their XY actions. And if you like this game, tell your colleagues about it so their students can enjoy it too. If you have feedback about this game, hit me up at gjennings@scdsb.on.ca. And again, thank you very much for showing up for your students learning. Bye for now, everybody.